We now come to the final section in this reading, which is economic growth and sustainability. Economic growth is measured as the percentage change in real GDP or the output of an economy. We can also look at economic growth as the change in per capita GDP. Per capita GDP is equal to the overall GDP divided by the size of the population. This is a good measure because it tells us whether an economy is getting better or not, whether the standard of living is improving or not. If GDP is up by 3% but the population is up by the same amount, then the income per capita or GDP per capita is not changing. On the other hand, if the GDP is increasing at a faster rate relative to the population, then the per capita GDP will be going up, which means that on average, people are better off. The sustainable rate of economic growth is the rate of increase in the economy's productive capacity or potential GDP. And these terms will be used interchangeably. They mean essentially the same thing, productive capacity and potential GDP. Potential GDP is the point at which the long-run aggregate supply curve intersects the x-axis. Just to check whether you have understood this concept or not, look at this question. What is the difference between saying that there is a 4% change in real GDP versus saying that there is a 4% change in potential GDP? As an investor, what will excite you more? Think about this for a second before you move on. Hopefully you got this, but it is important enough that I'll illustrate the point again. We have talked about these curves: aggregate demand, short-run aggregate supply, long-run aggregate supply. What you are looking at here is an economy which is in equilibrium. So this is long-run equilibrium because short-run equilibrium, intersection of aggregate demand and short-run aggregate supply, is on the long-run aggregate supply curve. This is the point which represents the potential GDP or the productive capacity. If we say that potential GDP is increasing by 4%, what we mean is that the long-run aggregate supply curve is shifting to the right, which means that the potential GDP or the overall capacity of the economy is going up. If we simply say that the real GDP is up by 4%, what that might simply mean is that aggregate demand is up. If aggregate demand is up, then in the short run, our real GDP has gone up, but it is possible for this situation to exist in the short run, even though our productive capacity is still where it was. So as investors, we'll be much happier with a situation where the long-run aggregate supply or the potential GDP has increased by a certain amount, as opposed to a situation where the equilibrium point or the real GDP has just gone up short term and eventually it might come back to the original point. So the answer is, what will excite you more? The 4% change in potential GDP will excite an investor more. Production function and potential GDP. According to the neoclassical model, which is also called the solo growth model, productive capacity or potential GDP increases for the following reasons. In case it is not obvious, what we are talking about now is the factors. What we are talking about now are the factors which cause the long-run aggregate supply to shift to the right. And as I have said several times, this means that our productive capacity or potential GDP is improving. So this moves to the right either because there is an increase in the factors of production. So we have more labor or we have more capital that will cause our productive capacity to increase. The other possibility is that we discover new technologies which make our existing labor and our existing capital more efficient. If we take a very simple instance of the neoclassical model, we can say that output is a function of labor and capital plus this thing called A. A represents total factor productivity and is a measure of efficiency. We have talked about the concept of a production function earlier in microeconomics, and we've also talked about diminishing marginal productivity. Let us look at how the concept applies here in macroeconomics. Think about a given economy, and let's say the x-axis here represents the amount of capital, and let's say the y-axis represents output. If you take a very simple economy where the output is mostly agricultural products and really basic methods are used for farming, in such an economy, if more capital is added, so instead of using bullock carts, we start using tractors, the increase in capital will cause the output to increase quite rapidly. But as we keep adding more capital, so more tractors, the output will go up but at a decreasing rate. And eventually, as you keep adding more capital, the increase in output will be marginal. So what we are looking at here is called diminishing marginal productivity. Output is going up but at a slower rate, and that is diminishing marginal productivity. There are two implications of diminishing marginal productivity. The first implication is that long-term sustainable growth cannot rely solely on capital deepening investment. Capital deepening is an important term, and hopefully it is self-evident. This simply means adding more capital. As we've seen here, adding capital increases output, but there are diminishing returns, and eventually the output will level out no matter how much capital we add. So we can't say that we'll keep increasing output simply by adding more and more capital. The other point has to do with a concept called convergence. Higher productivity of capital in developing countries should lead to convergence. Now, this is a theoretical concept which is touched on at a very high level here at level 1. We see this in more detail at level 2. In fact, this entire topic is covered in much more detail at level 2. But the basic idea is this. In developing countries, if we add more capital, our output will increase at a relatively fast rate, whereas developed countries might be somewhere over here. So adding 1 unit of capital in a developing country is going to have a substantially higher impact relative to adding 1 unit of capital in a developed country. So if we keep adding capital in a developing country, eventually the productivity will converge with the productivity of a developed country. Again, this sounds simple. In practice, we often don't see this happening. And again, this concept is discussed in more detail at level 2. Right now, you just need to know the basics. And if you've understood what I have just said, you should be in reasonably good shape for the level 1 exam. Growth accounting equation. This is an equation or a model which tries to explain where growth comes from. Simplistically, the equation says that the growth in potential GDP comes from growth in technology, so improvement in total factor productivity, better efficiency, plus WL, which is a coefficient, times the growth in labor, plus WC, which is a coefficient for capital, times the growth in capital. Another way of looking at these coefficients is that they represent the relative share of labor and capital in the national income. You don't need to get too deep into this, just remember this phrase. You can understand the concept at a basic level through the example shown over here. Let's say we have an economy where the growth in potential GDP is given by this expression, 2 plus 0.7 into growth in labor plus 0.3 times growth in capital. How do we interpret these three coefficients? The 2 clearly corresponds to growth in technology. The 0.7 corresponds to WL. So what this means is that the relative share of labor in the national income is 0.7 or 70%, and the relative share of capital in the national income is 30%. Another way of looking at it would be that if all else stays the same and labor goes up by 1%, then the growth in potential GDP would be 0.7%. Or if labor stays the same and we increase capital by 1%, all else stays the same, then the growth in potential GDP would be 0.3%. Again, that's 0.3% growth in potential GDP if the growth in capital is 1%. Growth in per capita potential GDP can be derived from here. Essentially, we are dividing by labor. The per capita potential GDP goes up based on growth in technology. If there is more technology, more efficiency, then each person is more productive. So this part of the expression stays. Instead of using WL times growth in labor, now that we are dividing by labor, we end up with this expression, WC into growth in the capital to labor ratio. And here there will be diminishing returns where as we keep adding capital, more and more capital to the same amount of labor, initially there will be a benefit, output will go up, but eventually we will hit diminishing returns. So in any case, remember this expression and remember this expression. You also need to be on top of the interpretation associated with the coefficients. Section 4.2, sources of economic growth, and the various sources are listed over here. To an extent we've already talked about these, but the point here is that if there is an increase in labor supply, then there will be an increase in economic growth. There is a fair amount of detail on this in microeconomic textbooks. The curriculum just says a little bit about each of these items. The overall labor supply, for example, is measured based on total hours worked, which is equal to the labor force times the average hours worked multiplied by the average hours worked per worker. Now, the definition of labor force is the portion of the working age population that is employed or available for work but not necessarily working. So unemployed people who are looking for work also are included in the labor force. Human capital refers to the quality of labor. So if the labor is better educated or better trained, then that also drives economic growth, and that emphasizes the importance of education and training. As we've discussed, when physical capital increases, that also stimulates economic growth. A term that you will keep seeing in this context is capital stock. This refers to buildings, machinery, equipment, etc. The term technology is used in a very broad sense in economics. Technology refers to improvements in efficiency. So if a process is introduced that makes production more efficient, that would also come under technology. Better technology, more efficiency leads to economic growth. These improvements are very difficult to measure though. The term that I have used before is total factor productivity, and in our model this was referred to as the symbol A, but you should remember the term total factor productivity. This is a measure of efficiency. And if we must calculate this, then we need to work backwards to come up with this number. If you recall the growth accounting equation that I just showed you, we said that the growth in potential GDP is equal to growth in technology or total factor productivity growth, plus we had a coefficient times the growth in labor plus another coefficient times the growth in capital. From this we can compute the growth in technology as the growth in potential GDP minus these two terms. This material, as I mentioned before, is covered in a lot of detail at level 2. I think the most complicated question that you might get on this in the exam would be one where all but one of these terms would be given to you and you would have to find the one term that is not given. So recognizing the growth accounting formula and being able to just plug and play is important. And finally, natural resources. Obviously, if there is an increase in natural resources, that will stimulate economic growth. Now take a look at example 15 in the curriculum. Measures of sustainable growth. We have talked about potential GDP and about using the growth accounting formula to measure changes in potential GDP, but it is very difficult to measure potential GDP and it is even harder to measure total factor productivity. So what many economists do is focus on labor productivity, which is easier to measure. Labor productivity is simply real GDP divided by aggregate hours. And here is an expression that we've seen before. Output per unit of labor is equal to total factor productivity. And then we have a function of capital per unit of labor. If we have higher labor productivity, then we will have more goods and services per person. The growth of labor productivity simply means that there is an increase in productivity over a year. So the growth rate here is the percentage increase in labor productivity from one year to the next. Labor productivity can be used to estimate the rate of sustainable growth of the economy, and this is important. Let's see how we will do this. Potential GDP is equal to aggregate hours worked into labor productivity. And this is fairly self-evident. Labor productivity is the output per hours worked, and then we multiply that by the aggregate hours worked, so that gives us the GDP. The growth rate is shown like this. If we make an approximation of the first equation, we come up with something like this. This is converting into a growth rate. So the potential growth rate is equal to the long-term growth rate of the labor force plus the long-term labor productivity growth rate. Simplistically, what this formula is saying is the following. The potential growth rate is based on the growth rate of the labor force. So if the labor force grows by approximately 1%, that obviously contributes to the potential growth rate, plus the long-term labor productivity growth rate also contributes to the potential growth rate. If the labor productivity grows by 2%, then approximately speaking, the overall potential growth rate is equal to 3%. And notice the two components of the potential growth rate are the growth rate of the overall labor force and then the growth rate of productivity or the improvement in productivity of labor. Now I want you to do examples 16, 17 and 18 from the curriculum. We have finally come to the end of this very long reading, and here is a summary of the main points. You need to know how to calculate and interpret the GDP. We talked about two interpretations of GDP. One was based on expenditure and the other based on income. Expenditure-based GDP was as follows: consumption plus investment plus government spending plus net exports. With the income-based approach, we say that the GDP is equal to the national income plus depreciation, which is measured by something called CAA, or capital consumption allowance, plus a statistical discrepancy. And I showed you a potential question related to this material. You could be given all these numbers and you could then be asked to calculate the GDP, and then you could be asked to calculate the national income, and all you would have to do then is to take this GDP, subtract CAA and statistical discrepancy to come up with the national income. Also recognize that there is a breakup of the national income that we talked about, and you need to know that breakup. Nominal and real GDP. Nominal GDP is based on output and current market prices. Real GDP is based on output and the prices from the base year. So real GDP is a measure of the actual output and it takes out the impact of inflation. National income, personal disposable income. We've already talked about national income over here. You need to know the formula that takes us from national income to personal income. This is the income that people receive, but we also need to recognize personal disposable income, which is personal income minus personal income taxes. This is an important number because it tells us about the consumption appetite of society. Savings, investment, fiscal balance and trade balance. We talked about a relationship which combines all these terms, and this is an important relationship which you need to be on top of. There are several forms of this expression, but here is one that I would encourage you to remember. Savings minus investment is equal to the fiscal deficit plus net exports. IS, LM and aggregate demand curves. Complicated topic, but I'm going to give you the most important information over here. The IS curve shows real interest rates against output or income, and this shows a negative relationship between these two variables. You need to recognize that along this curve, income is equal to planned expenditure. Then the LM curve is upward sloping. This shows the relationship between R and Y, where the quantity supplied of real money is kept equal to the quantity demanded of real money. So money markets are in equilibrium. Then it can be shown by combining the IS curve and the LM curve that we have a downward sloping aggregate demand curve where we have price level on the y-axis and output or income on the x-axis. In all these curves, the x-axis represents real output or real income. Sometimes you might also see real GDP because GDP is the real output or real income. And we have gone through a long derivation, but very simplistically put, if you are at a given point where we have a certain price level and a certain output, and we have shown that when the price level decreases, then the LM curve shifts to the right and our income, real income, increases. And that can be shown over here. Price level down, real income goes up. So that is the very brief derivation of the aggregate demand curve using LM and IS curves. We then talked about the aggregate supply curve, and remember that we have several aggregate supply curves. The most important ones that I will show you over here are the short run aggregate supply and the long run aggregate supply. The long run aggregate supply is a vertical line. Short run aggregate supply is a line that looks like this. It is upward sloping. The long run equilibrium point is where the three curves that I have just shown you intersect. The long run aggregate supply tells us about a potential GDP or the potential output that a given economy can produce. The intersection of aggregate demand and short run aggregate supply tells us about the short term equilibrium GDP point. At times where these two curves, the aggregate demand and short run aggregate supply, if they intersect to the right of potential GDP, then we say we have an inflationary gap. If they intersect to the left of long run aggregate supply, then we say that we have a recessionary gap. We talked about shifts in the aggregate demand curve and the aggregate supply curve. You need to go over the exhibits which I showed you. They were fairly intuitive. You also need to recognize that the shifts in the aggregate demand curve and aggregate supply curves have an impact on the economy. When the intersection of these two curves is away from the long run aggregate supply curve, that's what causes the business cycle. And the business cycle is something we will discuss in more detail in the next reading. That's why I did not spend too much time talking about the business cycle in this particular reading. And finally, economic growth. You need to recognize the factors that result in economic growth. By economic growth, we mean the growth in the potential GDP, which essentially means moving the long run aggregate supply curve to the right. And how does this happen? This happens if we have more factors of production or if we have more efficiency. In other words, either more labor or more capital or more natural resources, or the factors of production are used more efficiently, and that efficiency is called technology. It is generally denoted by something called total factor productivity. Those are the most important points. Make sure that you go over the summary in the curriculum, review the learning objectives. What I have tried to do in this very long reading is at least cover all the learning objectives. So go over those objectives and make sure that you can say something sensible about each one of the objectives. I have asked you to do the examples. Some of them are fairly long. Don't get too hung up in the mathematics or the algebra. Just try to get a good sense for what the examples are telling you, but the amount of time you spend on these examples should depend on the amount of time that you have left for the exam. Remember, economics is 10%. This is one of 9 readings, so maybe this reading is 1 to 1.5% of the exam. So don't get too hung up on the reading or on the examples. You must do all the practice problems. The practice problems are great and they are the best indication of what you might see on the exam. If you have time, also do practice questions from other sources. That is it.